Okay, I'm going to consider a new concept. I'm going to consider the subgroup generated by a subset. So suppose we have a group G, little circle, and I've got X, a subset of G. So this is a set inclusion. Then we write X in square brackets equals the subgroup generated by X to be that. And this is the smallest subgroup that contains X, or slightly more abstractly, the intersection of all subgroups containing X. And the way to think about it is this. Suppose X equals the set, call it X1, X2, X3, no, just X1, X2, X3. Let's just take that. Then the subgroup the subgroup generated by X, well, we can't say for sure exactly what it is, but it's going to contain X1. And it's going to contain X1 to the minus 1, and it's going to contain X1, X2, and it's going to contain X2, X1, which might be different, might be the same, but it might be different. And it's going to consider X3, X1, and X3 on its own, and X3 to the minus 1, X2 to the minus 1, X3 to the minus 4, and so on. It's going to consider all of these, it's going to contain all of these things. Some of them might be the same. Some of them might be the same. Some of them, these two, for example, would be the same if the group was abelian. But this might be the same as that, because of some structure which is present in your group. So let's just consider the subset. Let's consider the subset generated by X, where X equals the set containing just one single element, X. So what's that? Well, we know that X is a member of that. The identity, E, is going to be a member of X, and X squared is going to be a member of X, and so on. Oh, and of course X to the minus 1 is going to be a member of X. So, just starting with E, we might end up with E, X, X squared, X cubed, X to the 4, X to the n, and this sequence might continue forever, in which case, oh, and of course we can go backwards as well, because we've got X to the minus 1, X to the minus 2, and so we've either got Z, or there might be an n, a smallest n, with X to the n equals the identity, in which case we've got Cn, which is the cyclic group of order n. So, the subgroup generated by a single element is either cyclic for some n, or the whole integers. And I'll consider some more complicated examples in the next screencast, but I'm going to stop there.